All right, so this is going to be our second stab at trigonometry, and we're going to be talking about not just the tan ratio, which is what we did before. We're going to be looking at two new ratios, which are called sine and cos. Okay, we'll get to what those mean in a minute, but basically you're going to be solving similar idea where you have right angle triangles and there's missing information. We're going to use a lot of the same skills, so let's talk about reviewing those skills to start. So we used to label triangles and we called them adjacent, opposite, and hypotenuse. We still have to be able to label these triangles. It's really important. So on this triangle I have right here, important thing to remember is whatever angle you're using is going to be important to deciding what the other sides are. So adjacent is the fancy math word for beside. So on my triangle right here, I know that this side of the triangle is the adjacent because it's right next to the angle. Opposite is the side that is across from or opposite from the angle. So if I look at this side is opposite, so I'm going to call this side opposite. Okay, this one's the adjacent, this one's opposite. The hypotenuse is the longest side, and it's also the one that's across from the 90-degree angle. So this is going to be my hypotenuse. Okay? If we look at this second triangle right here, the angle's in a different spot, which means some of the angles are going to be, or some of the sides are going to be labeled differently, even though it might be the exact same triangle. So the adjacent side would be this one because it's right next to it. The opposite side is over here, so it's going to be the opposite. And the hypotenuse across from the 90 is actually still the same. Okay? Being able to label these three sides is really important, and we're going to do it in every question. So let's recap tan ratio. The first thing we always do is label our sides. So I have my angle here, so that means this is adjacent. This side's adjacent. This side's opposite, this side's hypotenuse. I'm going to do this one really quick too. This hypotenuse that's across, this side's adjacent now, and this side's opposite. I really suggest you always label those sides, just write it in pen on your question or in pencil, whatever, just so that you can actually see it so you don't forget to do it later. So our tan ratio, if you remember, was tan theta is equal to opposite over adjacent. Okay, so we're going to take the information we have on our sheet and fill it in. So looking at this, we want to know this missing side right here, and we don't have it, but we do have the opposite and an angle. So I'm going to sub in all the numbers I know. In my equation, opposite's right here, so I'm going to sub in the number for opposite, which is 8. So that becomes 8. The adjacent in my equation is right here. It's x, so I'm just going to label that x. X. Okay? The last thing, this theta, that's the angle. Okay? Whatever angle that we're working with. So in this question, it was 40. So I am going to write 40. So the very last thing we have to think about is in this question, we have it set up with all our information here, which is good, but we don't have x by itself. So we're going to rearrange so we can isolate. So what we're going to do is we're going to actually like switch these two, or if you want to think about it, that we're multiplying by x, it doesn't matter, but so it turns into this. So x goes here, and the tan 40 goes there. So it's going to become x equals 8 over tan 40. Okay. When you put that in your calculator, you can just do it all in one step. You press 8 divided by, and then some calculators you have to press 40 first, some you have to press tan first. It's up to you to figure out which calculator you're working with. When I do it, I got x equals 9.53, and I look, this was a side, so that would be centimeters or inches or whatever, okay? Cool. Now, let's do a second question right here, just to recap. It works the same way. I'm going to start with my equation again. So we got tan theta equals opposite over adjacent. Okay. But instead, this time, we got to put in different numbers. So the adjacent was 9. The opposite side over here was 7. Ooh, let's make that a nicer 7. And tan, I didn't actually know the angle. It was tan x. So the way this question works is we want x by itself. So to do that, we have to actually move the tan to the other side. So it's going to look like this, and this is where we do the inverse tan, or the second function tan on your calculator. Okay? And then 7 divided by 9. Make very sure that you put these numbers into brackets, because if you don't, you'll probably do inverse tan of just 7, and that'll be wrong. It needs to be the inverse tan of 7 over 9, which is like 0 point something. It's a decimal. So when I put that in my calculator, I get 37. X equals 37.87. And this is an angle, so I'm going to write degrees. This was all recap. Okay? This is the major skills we talked about. But if you're able to do all this stuff, the new things we're going to look at are going to be really easy. So let's scroll down, and we're going to talk about this thing, SOHCAHTOA. Okay? So the idea with SOHCAHTOA is just a way to remember the different ratios. We already did tan theta equals opposite over adjacent. Okay? If you were able to remember that, that's awesome. But this can help us to remember the rules. So you have to look at these letters, and they tell us how to set up the ratios. It's always going to be sine, cos, or tan, and then the angle, which I write as theta. It's not a 0, it's a symbol, kind of like x. And then it's going to be a ratio. So I'm actually just going to move this over a tiny bit. Okay? And then the cos one is cos theta equals something over something. So as you can see, they're all ratios. The ratios that we're actually going to use are in the question, or in this SOHCAHTOA thing. Okay? So SO is SOH. So the O is the opposite, and the H is the hypotenuse. So you can see, if you look, it goes SOH. So. Okay? And then the cosine one is, in our question, in our equation thing, it said CAH, C-A-H. So that's going to be cosine, and then adjacent, and then hypotenuse, C-A-H. Okay? And then the last one is TOA, which we've already done, is T-O-A. Honestly, you're able to use a reference sheet which has these equations on it. This is just a way to remember what they look like. So these equations are really important. What you have to do now is decide which one to use. In all our previous ones, we always just use tan, but now there's 3 options, and you have to decide based on what the question gives you. So let's actually take a look at an example, and we can figure it out. So let's take a look at this one on the left. Okay? Again, the first thing you're going to do, label all the sides. This is our angle. So this side is going to be the adjacent, this is going to be the opposite, and this is going to be the hypotenuse. I know that I'm using this side, the hypotenuse, because it gave us the number. And I know I'm using this side, the opposite, because it gave us the x. I don't really care about the adjacent, so I'm going to ignore it. I can even erase it if I want. Okay? So I have the letter H and the letter O. So the only equation that uses the letter H and the letter O is sine. So my first step is I'm going to have to write the equation right underneath it. Sine theta is equal to opposite over hypotenuse. And then we're going to solve it. And I'll show you how to solve it in a sec. Let's set up this question first, just to make sure we understand what's going on. I'm going to label the sides again. So this is our angle. So that means that this side's adjacent, this side's opposite, but we're not using it, so I don't care. And then this side's the hypotenuse. So I have H and A, which means I'm going to be using cosine because it has A and H. So let's write that equation out. It's going to be cos theta is equal to adjacent over hypotenuse. So now what we're going to do, let's go back to this question. Okay. The first step, like we said, was always write the equation, which I did. Now I have to sub in the numbers. This works the exact same way as the tan one, especially if you labeled your triangle properly. So I got sine. Then we have an angle, which was our 20 degrees. So I'm going to write sine 20. Oops, sorry about that. Okay. We have sine 20 is equal to opposite, which was x in this case, hypotenuse, which is 10. Cool. So now I want x by itself. So that means I'm going to have to multiply both sides by 10 to move it to the other side. So it's going to become 10 times sine 20. And if I put that into a calculator, I end up getting 3.4. Okay? Which would mean that this side, the x that we solve for, is 3.4 centimeters long or whatever. This question works the same way, this one on the right. I'm just going to sub in the numbers. So I have let's make it blue. Cosine 20, because again, we had 20 degrees in our question, is equal to adjacent x, I don't know what it is, over hypotenuse, which was 10. Nicer 10, okay? We want x by itself, so I'm going to multiply again, move this over. So it's going to become 10 times cos 20 is equal to x. And when I put that in the calculator, please note that even though this looks very similar to the last question, because it's cosine instead of sine, it's actually going to end up giving us a different number. So I do 10 times the cosine of 20, and that gave me x is equal to 9.39. And again, this is the side length of centimeters, inches, whatever. Okay? So solving isn't that difficult. You just need to label your triangle properly and then sub it into the equation. This is the last one, and it's a little more challenging, but you already know how to do it. This is where you have missing angles. We're going to set it up the same way. So my first step, I'm going to label the sides. So let's just do this question in its entirety. So I have this is my angle, which means this is adjacent, this is opposite, and this is hypotenuse. I know I'm using opposite and hypotenuse, which means I have to use, if I look at SOHCAHTOA, okay, I know I have to use the sine, because I have opposite and hypotenuse. Sine theta is equal to opposite over hypotenuse. And let's sub in the numbers. Sine, I don't have the angle, so I'm going to call that sine x. The opposite it gave us was 7, and the hypotenuse it gave us was 10. So now I need to move sine to the other side, just like you would with tan. So this is where it becomes x is equal to the inverse sine 7 over 10. Remember, when we move that sign, it becomes the inverse, the second function. And then you just sub it in your calculator. Whatever that gives you is the answer. So I got 44.42. We are dealing with an angle, so that's degrees. We're going to do the last one. It works, again, the exact same way. So think for a sec before I tell you, what's the first step you do? If you were doing a question like the one that we see right here, this triangle, solve for x, what would be the first thing you would do? Hopefully you said label the triangle. So we have adjacent, and then opposite, and then hypotenuse. I'm not using the opposite, but I am using the adjacent and hypotenuse. So which equation would we use of these three? Think for a sec. We're definitely using the cosine one because we have an a and an h. So I'm going to write the equation. Think of what the equation would look like. Cosine theta equals adjacent over hypotenuse. Now think for a sec, what would we do next? I'm going to sub in the numbers. So it's going to become cosine x for our angle is equal to 5 over 12 because I use the adjacent and the hypotenuse. Okay. We know the question wants to be x equals, so what do you have to do with this cosine? Think for a sec. Okay. You got to move the cosine to the other side, which means it's going to look like this. Inverse cosine, you do 5 over 12. Try that on your calculator. Make sure you get the right answer. When I did it, I got, let me do it right now. Oops, sorry about that. And then I got 65.3. 65.3. Has not cooperated. Okay, 65.3, and because it's degrees for an angle, I'm going to write the degrees right there. And that's it. That's the skills of how to do it. Almost every single question is the same. The only difference is it might be word problems or whatever. Okay, you take your triangle. You then draw. You label the sides, hypotenuse, adjacent, whatever. Then you write your equation based on what you have. Sub in the numbers and solve. That's every single question for this unit. If you can get over those skills, you do great in this unit.